So that is called the adhesions. That is called the adhesions. So it means that the tooth is naturally materials in our mouth. And when we put the dental materials over there, that means the tooth and the dental material, they are two dissimilar materials. That is called the adhesions. But the cohesion means similar materials, like the water molecules. They are the same materials. When you mix a water and water, that is called the cohesions. Glass materials come together, that is called the cohesions. So similar means cohesions, dissimilar means adhesions. Okay. So the reason I give that example, that can be useful for you to memorize what is the additions and what is cohesions. Or you can think about other examples that can help you too. So additions, as you can see here, the ability to the two unlike materials to adhere or stick to each other. That is called the adhesions. And these adhesions, without the proper adhesions, the microleakage can occur, and it can be the one of the cause of recessions to come out. So I put the materials on the tooth surface, but they are not properly attached. They are not properly joined together. What will happen? After a few days or few hours or few years, they will come out. So that's why the adhesion is very important. So now for the addition of the materials, we need to think about the properties. What are the characteristics of the dental materials that will affect this capability? If this additions capability is not following their following characteristics, then it will be affect the addition process. Affecting addition process means it will be easily come out. But we don't want anything like that. We want the materials to stay on the tooth surface. But this staying of the tooth surface, it will depend on four things. Number one is wettability. Number two is viscosity. Number three is surface characteristics. And number four is film thickness. So as I mentioned that water and honey, so water will be more first pouring on the surface. So if you have a materials, if you apply the metal on the tooth surface and they are not flowing properly on the surface, they are not weighting the surface, then what will happen? They are not covering the surface area and they are giving a very, very thick thickness, they will come out. But if we apply the material, they will flow easily. They will cover the surfaces. They will be covered the surface easily when they are less viscous, right? And then they will be follow the characteristics of the all the surfaces to cover, and they will influence the weighting ability. And then the thickness will be very thin, and this will be give a proper adhesions. So you want a good bonding. We want the good bonding between the materials and the tooth surfaces. If the bonding is not proper, then it will be difficult for the dental team members to, the hold the materials inside the patient's mouth, because the patients they want the guarantee. So there is no guarantee even. The sometimes you will see the patients want, okay, if I put these materials, how many years it can serve me? So this is not a good question to ask, because there is no guarantee in the medical science. There is no guarantee and warranty in the medical science. But even though sometimes some dental surgeons, oh, if I put these materials, it can last for 5 years, 10 years, something like that. So that actually just they talk. It's not there is no scientific base on it. Okay, scientific base, there is no scientific base on it that if I put the materials, it can last long. But if I, during putting my materials, if I put all this, protocol, it can be last long. That we can say maximum. Retentions, that is another very important part. Retention means the way it will be ability to hold the two things together. Okay, the ability of the two things together when they are not adhered to each other naturally. That is called the retentions. So ability of holding the two things firmly together when they are not adherent to each other naturally. That is called the retentions. And we want the retention because the dental materials or restorations, castings and appliances, they must have in place with the use of materials and the retention method. So tooth structures and the metal, say in our tooth, we have calcium, phosphates, all these fluorides, all these minerals. Think about the metal filling. It contains the silver, tin, copper, zinc. So there is two things. One is metal, silver, tin, copper, zinc present in the amalgam. And in the tooth, we have the calcium, phosphates, and fluorides. So now how these two things come together? Definitely there should be some retentive method. If there is no retentive method, then it will not be stay in the patient's mouth, right? So there should be some retentions. Say as for example, for composite. For composite, we have inside the materials, we have the resin materials, which is the plastic materials. But our tooth is not plastic. Our tooth contains the calcium and phosphates. So that means they are two dissimilar materials. They need to come together. Same thing for the glass ionomer. It contains the fluoroaluminosilicate powder, which is a glass powder. And our tooth has calcium and phosphates. So they are two dissimilar. That's why the retention is the process by which these two dissimilar materials come together and stay together and give the support for the patient to chew the food. So that's why the dental materials or dental restorations, casting and the appliances, they must be held in place with the use of materials and the retentions method. And there are three retention method. This is very important for everybody to remember. There are three ways the tooth materials will be attached with the dental materials. What are those three? One is chemical bonding. One is micromechanical bonding. One is mechanical bonding. So mechanical bonding, micromechanical bonding, chemical bonding. Example for chemical bonding is glass ionomer. Chemical bond, example of the materials is glass ionomer. That means the glass ionomer materials, they will be attached to the tooth surface by the help of chemical reaction. On the other hand, all kind of composite materials, they will be attached on the tooth surface by micromechanical retentions. And the amalgam, gold, these type of metal restorations or metal filling, they will be attached on the tooth surface with a mechanical retentions. Okay. So even though retention hold the materials in place, it does not completely seal the two surfaces together. Sometimes we see that there is no, there is a micro gap can be seen in between these two type of materials. So that's why the micro leakage is very common problem in case of the composite filling materials. The reason is it is by nature. By nature, the material is shrink. Materials, once we applied, when they react to each other, they will be shrink. When they shrink, they will make a micro gap. So that's why sometimes we are not able to get a complete sealing between the materials and the tooth structures. We are not able to see them in our naked eye, but we will able to see them under the microscope. So that is the retentions. Now the next is the curing. Curing means the dental materials, they need some sorts of energy to bond together, to complete their reactions. So the materials, they will react to each other by themselves. That is called the auto-cured. That means we want the materials to become soft, palleable, soft, palleable. But at the same time, once we are complete the pouring on the tooth surface of the materials, we want the materials to become hard. So for hardness, it need to do some reactions. It is called the setting process or setting process of the dental materials. You mix the materials, materials come with powder and the liquid. So powder and the liquid, you mix them together. with following the manufacturer instructions. After mixing, the materials become very soft. So these soft materials, when we try to put in the patient's mouth, we want them the soft so that it can flow easily on the surface. Once it's flow easily on the surfaces, then immediately we want the materials to become very hard. So how this is possible? It is possible due to their reactions. And that reactions can be done by the materials itself, or it can be done by the application of the light to apply some sorts of external energy, or it can be done both reacting and light. So that's why the curing process can be done by three way. As you can see here, the setting process of the dental materials that is initiated. Initiate means starting the reactions. Initiated by a chemical reactions. So these chemical reactions are by the light. Either they will reacting to each other or they will be reacting by the presence of the light. And you will see that in the dental clinic, the dentist using sometimes blue color of light. So this blue color light actually give the energy, which is about the 420 to 460 nanometer of energy. So this energy is radiating, it's coming down when you apply the light. The light give the energy. So this 460 to 420 nanometer of energy will apply by the curing light, and that will help the materials to react together, to bond together. So that is called the light cure because it is cured by the light. If it is not cured by the light, it is just reacting by itself. We call them the auto-cure. As you can see here, the auto-cure materials hardens as a result of the chemical reactions of the materials once they mix together. That is called the auto-cure. Light cure means, by name you can understand what is the meaning of that. The light cure materials does not harden until it has been exposed to a curing light. That means after exposing to the curing light, the materials will going to be hard. And the dual cure, you know that nowadays we have the dual car, like half of the car engine is operated by the what we call like the electricity, and another option is the diesel or gasoline, whatever we have. So the dual car, right? So that means it has both options. So here the same thing. Dual cured materials means it also have a both options. That means the some portion of the materials takes place by the reacting to each other, but its final curing has to be done with the light. That means it is the final cure does not occur until the materials has been exposed to a curing light. So it means that initial reactions may be started, it may be, like a little bit hard, not hard enough, and its final curing will take place when we apply the light. So this is the way usually the dental materials are placed in the patient's mouth. And that is the basic information regarding the dental materials. So here it is talking about the in general. In general, all the characteristics we learn from these discussions that the materials how they will apply and what they need to be have their properties, and also how they will be the hardened enough from the soft palleable state to the hard stage. Because if the materials you mix and it is hard immediately, it is very difficult to put in the patient's mouth. So it means that we need a more working time. We call them the working time and setting time. So working time means you are trying to dispensing the powder from the bottle. You are trying to dispensing some sorts of liquid, specific liquid for the materials to mix. So dispensing powder and the liquid come together in a place where you will mix it, and you are trying to mix it properly. So that means that is your working time. So we need a more working time. So once we mix it, the working that is called the working time because we are working, we are mixing. So that is called the working time. After mixing is done, you will transfer these materials into the patient's mouth. Now, when you're transferring the patient's mouth, that is also part of the working time because you are transferring. But once it's transferred is done, And once the dental surgeons is place the materials inside the patient's mouth, before the placing the patient's mouth, that was the working. But once we place in the patient's mouth, then we want the materials to set. The reason is oral cavity is not a good environment for the materials to be set, but we want them to set. So that is means once the working time is done, then we want the materials to set immediately. That is called the setting time. So it can be like 1 minute or maybe 30 seconds or maybe 12 seconds, something like that, or 30 seconds. So this is the way the different materials has a different way of mixing and way of setting together. Is it clear for everybody up to this point? Because the next part of the presentations will talk about the individual materials. So this is as a whole. Whatever we discuss here, the curing, retentions, adhesions, flowing, these are the application properties, soluble properties, corrosive properties, electric properties, thermal properties, and malleability and ductility properties and general properties. This is in general, all these dental materials has to be these properties. Okay, otherwise they will not be considered as a dental materials. So now the next part of the presentation is we'll talk about the individually about the characteristics of amalgam, composite, glass ionomer, zinc oxide eugenol, gold and inlay, and the ceramics. And that is actually the part of these presentations. So we have to understand about the basic properties of the dental materials. Okay, is it clear? Anybody in the class? Any questions up to this point? Say something, yes, no, or I don't understand this part, or I understand this part,
No.
or maybe, or
No
maybe,
question.
or you maybe say that, okay, maybe we need to go by ourselves to see something, to read something. Say something.
True.
Yeah. Yeah.
Are we going for a break now?
After 20 minutes.
Okay.
So now the next is we will go for the